Long before the Congo River comes into view, its roar carries through the jungle. Through the dense equatorial jungle surrounding Livingstone Falls comes a continuous roar, carried through the forest by water moving with extraordinary force. And somewhere beneath that surface, the river drops to a confirmed depth of roughly 720 feet. The Amazon reaches around 330 feet at its deepest. The Congo is more than twice as deep, but depth is only the beginning. In 1874, journalist and explorer Henry Morton Stanley began an expedition across Central Africa with 356 people. 999 days later, he reached the Atlantic with only 114 survivors. Every European companion who had started the journey with him was dead. More than a century later, the river was still taking experienced people. In 2010, renowned African river guide Hendry Coetzee was kayaking on a tributary in the Congo Basin when a crocodile pulled him from his kayak in front of two companions. His body was never recovered. Yet some of the Congo's strangest dangers exist, where almost no human can see them. In sections of the lower river, sunlight never reaches the bottom. Fish live under pressures so extreme that individuals swept rapidly toward the surface have been found suffering injuries consistent with decompression, something normally associated with deep sea environments. And when the Congo finally reaches the Atlantic, its influence does not simply disappear at the coastline. An enormous submarine canyon extends hundreds of miles offshore, carrying sediment from the river deep into the ocean, a river more than twice as deep as the Amazon. Expeditions that ended with hundreds missing or dead, animals living under conditions normally associated with the deep sea, and a system whose reach continues far beyond the African coastline, and we have barely entered the water. Tonight, we're going deeper into the Congo to uncover what makes this river unlike anything else on Earth. But before we do, let me know in the comments. Are you listening to this to fall asleep, or you're here only for the knowledge? Now, let's get into it. Before the Congo can be understood as one of Earth's most dangerous rivers, it must first be seen for what it truly is. It stretches far beyond the ordinary idea of a river winding toward the sea. From its earliest waters in the highlands of northeastern Zambia, the Congo begins a journey that sweeps across the heart of Central Africa in a broad counterclockwise arc before finally reaching the Atlantic Ocean. That path extends for approximately 2,920 miles, making it the ninth longest river on the planet, although length alone reveals very little about its true character. The basin surrounding this river covers roughly 1,300,000 square miles across 10 modern nations. Only the Amazon basin spreads across a greater area. Every stream, marsh, and tributary feeding this immense network contributes to a drainage system so extensive that weather patterns, forests, wildlife, and millions of people are linked by the same moving water. Looking at a map, the Congo resembles the circulation of an entire continent rather than a single river flowing between two points. Its volume tells an even greater story. Every second, about 1,250,000 cubic feet of fresh water pour into the Atlantic Ocean. For comparison, the mighty Mississippi River releases roughly 590,000 cubic feet each second. The Congo carries more than twice that amount, maintaining a relentless movement that never truly pauses. Across every hour of every day, an astonishing mass of water is pushed toward the coast with remarkable consistency. Around this river grows the Congo rainforest, the second largest tropical rainforest on Earth. Covering approximately 500 million acres, it shelters extraordinary numbers of plants, insects, birds, mammals, reptiles, and amphibians. The forest also stores immense quantities of carbon dioxide, earning it the familiar description as the planet's second lung. River and forest exist together as one living system, each shaping the other through rainfall, evaporation, and constant renewal. Human history has unfolded beside these waters for more than 50,000 years. Countless generations built communities throughout the basin, learning its seasonal rhythms, navigating its channels, and depending upon its fish, fertile soils, and surrounding forests. This makes the Congo Basin one of the longest continuously inhabited regions anywhere on Earth, where human experience has accumulated over thousands upon thousands of years alongside the same flowing current. Geographers often divide the river into three broad sections. The upper Congo begins near its source and continues toward Boyoma Falls. The middle Congo forms the great sweeping arc that dominates the center of the continent. Then comes the lower Congo, the shortest of the three, where the landscape tightens, the current accelerates, and familiar expectations about rivers begin to fall away. Although the lower Congo measures only about 200 miles in length, it contains nearly everything that separates this river from every other freshwater system on the planet. Here, the immense flow is compressed into a landscape shaped by extraordinary forces, preparing the conditions for discoveries that remained hidden from science until 2009, when researchers finally confirmed a depth unlike anything previously measured in a river. There comes a point along the lower Congo where familiar expectations about rivers disappear, replaced by measurements that seem better suited to the open ocean. Between Malebo Pool and Pioka, within the Democratic Republic of the Congo, the river reaches a confirmed depth of approximately 720 feet. That number alone shifts the entire conversation. Rivers are expected to spread wide, carry sediment, and gradually release their energy. The lower Congo follows a different path, descending into depths that challenge long held assumptions about freshwater landscapes. A simple comparison helps reveal the scale. The Statue of Liberty stands about 305 feet from its base to the tip of its torch. If two of those monuments were placed one upon the other, they would still vanish beneath the Congo's deepest measured point, with roughly 110 feet of water remaining above them. Standing on the riverbank gives almost no hint that such an enormous vertical world exists below the surface, concealed beneath water that often appears no different from any other great river. Marine scientists recognize an ocean layer beginning around 660 feet, where daylight fades dramatically and increasing pressure begins shaping the lives of the creatures living there. This region is known as the mesopelagic zone, often described as the ocean's twilight zone. Parts of the lower Congo extend directly into that same depth range. It is a remarkable overlap, placing a freshwater river within conditions usually associated with the sea. Light struggles to reach those depths, while the weight of the water above creates an environment unlike any found in most rivers across Earth. The comparison with the Amazon becomes even clearer here. The Amazon reaches a maximum depth of about 330 feet, an impressive figure by any ordinary standard. Even so, it is less than half the Congo's confirmed maximum depth. Without that additional descent, the Amazon never develops freshwater environments exposed to the same extraordinary pressures found in the lower Congo. The difference is measured not only in feet, but in the kinds of worlds each river is capable of creating. For generations, nobody knew this hidden dimension existed. The discovery arrived only in 2009 when researchers from the United States Geological Survey lowered sonar equipment into the correct section of the lower gorge during a scientific expedition. Almost unexpectedly, The instruments revealed a depth that transformed understanding of one of Earth's most important rivers. A fact so fundamental had remained unknown until only a handful of years ago, reminding scientists that even the largest features of our planet can remain concealed far longer than anyone imagines. Researchers also emphasize that 720 feet should not be treated as the final answer. Large portions of the lower gorge have never been fully measured, leaving open the possibility that even greater depths remain hidden within sections still beyond careful survey. The deepest confirmed point serves as a verified minimum, while the true limit continues to wait beneath water that has revealed only part of its story. Sonar images offer another surprise. Instead of a broad floor covered by thick layers of mud, the bottom appears rough and uneven, marked by ridges, troughs, and exposed rock. Powerful currents scour away loose sediment, continually exposing the rugged landscape below. Every contour hints at forces still at work, patiently carving the river into shapes that no ordinary current could ever produce. A river does not reach extraordinary depth by chance. Every foot carved into the lower Congo tells the story of water that has spent countless ages forcing its way through resistant stone. The same process continues today, shaping the gorge with a persistence rarely matched anywhere on Earth. Even now, while the river races toward the Atlantic Ocean, it is steadily changing the landscape hidden beneath its surface. During its final 62 miles before reaching the coast, the Congo drops approximately 656 feet in elevation. That descent would already be impressive on its own, yet the comparison with the Amazon reveals something extraordinary. The Amazon loses the same amount of elevation across roughly 3,107 miles. The Congo compresses an equal vertical drop into only a tiny fraction of that distance, concentrating unimaginable force into a remarkably short stretch of river. The surrounding landscape narrows as the water advances, squeezing an immense flow into rocky passages that are sometimes less than 820 feet wide. Every second, between 1,400,000 and 1,500,000 cubic feet of water surge through this confined corridor. The river is no longer spreading across broad floodplains. Instead, it is being driven through a natural stone funnel that magnifies its speed and power with every passing mile. At several locations, the gorge tightens even further until the river occupies channels less than 300 feet across. Through openings narrower than many city blocks, the Congo forces a volume of water roughly equal to twice the entire discharge of the Mississippi River. The sheer concentration of moving water becomes almost impossible to picture. Every second, an enormous freshwater mass is compressed into spaces that appear far too small to contain it, producing turbulence unlike anything found in ordinary rivers. These conditions create the Livingstone Falls, a chain of 32 cataracts stretching across approximately 220 miles. Together, they descend nearly 886 feet from beginning to end. They are not the tallest waterfalls on Earth, yet by the amount of water moving through them, they stand above every other waterfall system. More water rushes through the Livingstone Falls than through Niagara Falls, Victoria Falls, or any comparable cascade anywhere on the planet. At such tremendous speeds, flowing water becomes a powerful geological tool. Every collision with exposed rock strips away tiny fragments, polishing some surfaces while breaking others apart. Year after year, century after century, those countless impacts deepen channels, widen fractures, and reshape the riverbed itself. The lower Congo remains an active construction site directed entirely by gravity and moving water, with no indication that the process has come to an end. The consequences extend beyond the landscape. Within the narrowest passages, the current possesses enough force to overwhelm the human body through pressure alone. A person entering these waters without protection would encounter forces capable of inflicting severe physical injury before ordinary drowning could even occur. Survival becomes a matter of resisting hydraulic energy that far exceeds human strength. This relentless movement leaves another mark that cannot be seen from the surface. As the water tears through the gorge, it creates invisible boundaries that few living creatures can cross. The same currents, carving deeper into ancient rock, also separate populations, dividing habitats into isolated pockets where life follows different paths despite sharing the same river. The lower Congo shapes far more than stone. Every torrent racing through its narrow gorges also influences the path of life itself, creating boundaries that cannot be seen from above. To a fish, these currents are not moving water alone. They become barriers as effective as mountain ranges, dividing neighboring populations into separate biological worlds, despite the astonishingly short distances between them. Researchers from the American Museum of Natural History set out to understand whether these powerful channels affected the river's wildlife as dramatically as they transformed its landscape. By examining the genomes of fish collected from opposite sides of the lower Congo, they uncovered an unexpected pattern. Some populations, living less than a mile apart, exchanged almost no genetic material with one another. Although a person could easily walk that distance across dry land, the fish remained effectively isolated because the river itself prevented meaningful contact. Scientists describe this process as microallopatric divergence. The name refers to populations becoming separated across remarkably small spaces by barriers they cannot cross. In the lower Congo, the barrier is neither distance nor land. It is the immense force of moving water. Rapids, whirlpools, deep channels, and accelerating currents keep neighboring groups apart generation after generation, allowing each population to follow its own evolutionary path while remaining astonishingly close to the next. The effect resembles what mountain ranges accomplish on land. Peaks and valleys divide forests, separating animals into isolated habitats where different characteristics gradually emerge over thousands of years. The lower Congo achieves the same outcome with flowing water instead of stone. Every powerful channel becomes a freshwater island, surrounding its inhabitants with currents strong enough to prevent regular movement between nearby habitats. Gene pools become separated, and evolution begins working independently on each side. According to the lead researchers studying these fish, no other river known to science produces species divergence at such a remarkably small geographic scale. Elsewhere, populations usually become isolated across many miles or through obvious physical barriers. Along the lower Congo, separation may occur across only a few hundred feet. The distance itself is insignificant. The current supplies all the division required, transforming neighboring waters into places as isolated from one another as distant valleys. Over time, these invisible boundaries have produced an extraordinary collection of endemic species. More than 80 kinds of fish living within the lower Congo exist nowhere else on Earth. Their ancestors once shared common origins, yet countless generations spent isolated by relentless currents gradually reshaped their bodies, behaviors, and genetic identities. They remain permanent residents of a river that never allowed them to leave. The contrast with the Amazon helps reveal how unusual this process truly is. Although the Amazon carries enormous volumes of water and contains powerful currents of its own, fish populations generally retain opportunities to mix across the river. Channels remain navigable enough for regular movement, preserving the exchange of genetic material between neighboring groups. The lower Congo operates under entirely different conditions, where movement itself becomes the greatest obstacle to survival and reproduction. This remarkable process belongs to the present rather than the distant past. Evolution continues within the lower Congo every day as isolated populations adapt to their own corners of the river. Across distances that millions of people living throughout the basin could comfortably walk in less than 20 minutes, nature continues separating lives that rarely meet. Among those isolated creatures, one species has traveled farther from ordinary existence than almost any other freshwater fish, becoming so completely adapted to its hidden environment that reaching the surface proves fatal. Among all the remarkable creatures shaped by the lower Congo, one species seems almost impossible for a freshwater river to produce. It belongs to a family of fish normally recognized for bright colors and keen eyesight, yet this one possesses neither. Known as Lamprologus lethops, it is the only blind cichlid ever documented, and every confirmed specimen has come from the deepest reaches of the lower Congo, where darkness and immense water pressure define daily existence. The fish bears little resemblance to the familiar cichlids found elsewhere across Africa. Its body is pale, almost completely white, with translucent skin revealing the faint outline of tissues beneath. Pigment has nearly vanished. Its eyes survive only as tiny vestigial structures sealed beneath layers of skin, leaving a smooth head without functional vision. The body itself is elongated and slender, reflecting a life adapted to immense pressure. At first glance, it resembles an animal recovered from the deepest parts of the ocean rather than one living inside a river. Its discovery followed an equally unusual path. Local fishing communities occasionally noticed strange white fish washing onto the riverbanks, already dead or close to death. Nobody had observed them alive within the river itself. Their appearance was unlike any known freshwater species, and their origin remained uncertain. Eventually, scientists studying these mysterious specimens traced them back to the deepest portions of the lower Congo Gorge, revealing that the river occasionally carried them upward from an environment almost impossible for humans to reach. The explanation lay in the same powerful hydraulic forces already shaping the gorge. Violent upwelling currents sometimes swept individuals from depths greater than approximately 520 feet toward the surface. There, the conditions changed with extraordinary speed. These fish had evolved beneath pressures comparable to those experienced within the ocean's mesopelagic zone. The ordinary pressure found at the river's surface, harmless to every other fish inhabiting the Congo, became fatally different for them. Scientists eventually succeeded in bringing a living specimen to the surface for careful observation. The results revealed the cost of leaving its natural environment. Gas bubbles rapidly formed throughout the fish's tissues as dissolved gases escaped from the body under the sudden pressure change. The process closely resembled catastrophic decompression syndrome experienced by human divers ascending too quickly from great depth. Internal tissues suffered severe damage within moments, and the animal could not survive the transition. This makes Lamprologus lethops extraordinary, even among deep-dwelling animals. It has become so completely specialized for one narrow environment that the upper waters of its own river function as an almost uninhabitable place. The journey from the depths to the surface represents only a few hundred feet, yet biologically, it resembles crossing into an entirely different world where the body can no longer operate under familiar physical conditions. Further evidence arrived through genomic research published during 2025. Scientists confirmed that the fish had done far more than stop using its eyes or body pigment. Over many generations, the genes responsible for developing eyesight and producing pigment had become systematically inactivated. Evolution had gradually dismantled functions that permanent darkness no longer required, leaving their traces preserved only within the animal's deoxyribonucleic acid. The remarkable story of Lamprologus lethops does not stand alone within the lower Congo. Other unrelated fish lineages have independently reached many of the same solutions, losing vision, losing pigment, and adapting their bodies to crushing pressure through separate evolutionary journeys. Yet while these hidden specialists occupied the deepest waters, another creature emerged within the river's violent currents above, growing into one of freshwater's most formidable predators. Power does not always reveal itself through size alone. In the lower Congo, it appears as a predator shaped by relentless water, one whose entire body reflects the demands of chasing prey through currents that overwhelm almost every other living creature. The river did not merely provide a home for this hunter. It forged every detail of its design, refining it within one of the harshest freshwater environments on Earth until it became something unlike the famous predators of any other river. Known scientifically as Hydrocynus goliath, its name comes from words meaning water dog, a reflection of the fierce hunting behavior that first impressed early naturalists. Adult individuals commonly grow between 4 and 5 feet long, with many weighing from about 90 to 110 pounds. Their bodies are narrow, muscular, and streamlined like living torpedoes, allowing explosive bursts of speed through rushing water where slower fish struggle to maintain control. Its most striking feature is its mouth, 32 long teeth locked together with remarkable precision, fitting much like the teeth of a zipper whenever the jaws close. Each tooth may reach nearly 1 inch in length, creating a grip capable of holding prey securely, even while both predator and victim are being driven through turbulent currents at tremendous speed. Escaping those jaws becomes exceptionally difficult once they close. Unlike many freshwater fish that consume weakened animals or search for easy meals, the Goliath tigerfish actively pursues living prey. Large fish make up much of its diet, although documented observations also include aquatic mammals, young crocodiles, and birds caught near the water's surface. Every aspect of its hunting behavior reflects confidence rather than opportunity. It accelerates rapidly, strikes with precision, and depends upon strength instead of numbers to overpower its target. The most turbulent channels of the lower Congo provide the ideal setting for this predator. Places where the current would quickly overpower an unprotected human become hunting grounds where the tigerfish enjoys its greatest advantage. Powerful muscles, an efficient body shape, and finely tuned balance allow it to maneuver through water that defeats many other animals. Conditions appearing hostile to nearly everything else become favorable to a hunter perfectly adapted to them. Comparisons with the Amazon's famous piranha often create a misleading impression. Piranhas are highly successful fish within their own environment, yet their lifestyle differs completely. They frequently feed as opportunists, scavenging when food becomes available and relying on groups for much of their effectiveness. Healthy adult humans rarely face serious danger from piranhas without unusual circumstances. The Goliath tigerfish follows another strategy altogether. It hunts alone, pursues large moving prey directly, and thrives within current conditions that would overwhelm a piranha long before any pursuit could begin. Its strength has also earned remarkable respect among anglers. For more than 100 years, Fly fishermen have pursued this species without a confirmed capture using traditional fly fishing equipment. Powerful runs, violent strikes, and the immense force of the surrounding current combine to overwhelm rods, lines, and even experienced anglers. Success depends upon overcoming not only the fish itself, but also the extraordinary river that shaped it. Even this remarkable predator occupies only one layer of the Congo's living world. Deeper within the river, where slower movement conceals different dangers, another ancient hunter waits. It relies neither on speed nor pursuit, and during 2010, it reminded the world that still water within the Congo can be every bit as unforgiving as its roaring rapids. Not every danger in the Congo announces itself through roaring rapids or overwhelming current. Some remain invisible until the final instant, concealed beneath water carrying suspended sediment and dark, organic stains that limit visibility to only a short distance. Within those conditions lives one of the most successful ambush predators on Earth, a hunter that has evolved to strike without warning and disappear almost as quickly as it appeared. The Nile crocodile, scientifically known as Crocodilus niloticus, ranks among the largest reptiles alive today. Exceptional individuals may approach 20 feet in length and weigh more than 1,600 pounds. Across Africa, this species is responsible for more documented human fatalities each year than any other member of the crocodilian family. It succeeds through patience, concealment, and explosive acceleration delivered within a fraction of a second. The Congo Basin and its many tributaries support some of the densest Nile crocodile populations recorded anywhere on the continent. Suitable nesting habitat, abundant prey, and extensive waterways create conditions where these reptiles have flourished for countless generations. For people traveling through the basin, calm water offers no assurance of safety. A smooth surface may conceal an animal resting only a short distance below, completely hidden from view. Nile crocodiles hunt by remaining motionless until prey enters striking distance. Their eyes and nostrils sit high upon the head, allowing nearly the entire body to remain submerged. When the attack begins, it is usually over before the victim realizes a crocodile is present. Murky water further favors the predator, preventing most animals from recognizing danger until powerful jaws have already closed. Few people understood these risks better than Henry Coetzee, a South African river guide. He earned widespread respect through first descents of numerous African rivers and years spent studying both crocodile and hippopotamus behavior. Every expedition reflected careful preparation. Before entering unfamiliar waterways, he established detailed safety procedures based upon experience gathered across many seasons of navigating some of Africa's most demanding rivers. In December of 2010, Coetzee guided American kayakers Chris Korbulik and Ben Stooksbury along the Lukuga River, a tributary connected to the Congo system. Their ambitious expedition sought to complete a historic journey linking the White Nile with the heart of the Congo Basin. Before departure, Coetzee reminded his companions to avoid riverbanks where crocodiles basked, to remain clear of dangerous eddies occupied by hippopotamuses, and to stay close behind his kayak throughout the journey. The group eventually reached a calm stretch of river. There was no visible white water, and nothing on the surface suggested immediate danger. The kayaks traveled only about 4 to 5 feet apart. Without warning, a Nile crocodile surfaced directly behind Coetzee, seized him, and pulled him beneath the water. His companions heard the attack unfold almost beside them, yet the assault happened too quickly for any rescue to be attempted. Coetzee's body was never recovered. Reports describing that section of the Lukuga River identified it as an area already known for dangerous combinations of crocodiles and difficult river conditions. Years of knowledge, careful preparation, and strict adherence to personal safety rules could not overcome a predator perfectly adapted to that environment. Comparisons with the Amazon again reveal an important distinction. Black caimans may reach similar lengths, yet documented fatal attacks upon healthy adult humans remain comparatively uncommon. Nile crocodiles throughout the Congo basin present a different record entirely. Their presence forms only one layer of danger, sharing the river with other animals whose impact upon human life is even greater across much of Africa. The deeper one looks into the Congo River system, the more its dangers appear arranged in layers rather than scattered at random. Every part of the landscape contributes a different hazard. Water, shoreline, forest, and even the smallest organisms combine into a network of overlapping threats, leaving remarkably few places where people or animals can move without encountering some form of risk. Along broad channels and sheltered coves lives the Hippopotamus amphibius. The Congo Basin supports some of the largest remaining populations of this enormous mammal anywhere in Africa. Mature males may weigh as much as 4,400 pounds, making them the third heaviest land animal alive. Their massive bodies suggest slow movement, yet they can run at nearly 19 miles per hour across open ground for short distances, moving with surprising speed despite their immense size. Hippos defend territory with exceptional determination. Boats, canoes, and swimmers entering their space may be attacked even when no obvious threat has been presented. Across Africa, they are estimated to cause approximately 500 human deaths every year, exceeding fatalities attributed to lions, leopards, and other large terrestrial predators. The Amazon contains no comparable animal occupying such a dominant role along its rivers, making this layer of danger especially distinctive within the Congo Basin. Stepping away from the water offers little additional security. The surrounding forests and riverbanks support an extraordinary collection of venomous snakes. Black mambas, capable of moving at speeds approaching 12.5 miles per hour, possess venom that has historically been almost universally fatal without timely treatment using antivenom. Nearby, gaboon vipers produce the greatest venom yield measured in any snake species, delivering enough venom in a single bite to kill multiple adults. Bush vipers, puff adders, cobras, and rock pythons complete a community of predators already formidable before considering the remoteness of much of the lower Congo. Medical care presents another challenge. Reliable supplies of antivenom remain difficult to obtain throughout many isolated regions of the basin. Even when treatment exists elsewhere, distance, transportation, and limited infrastructure may delay life-saving care beyond the time available. In these landscapes, survival often depends as much upon geography as upon the bite itself. The river introduces another hazard that cannot be seen at all. Schistosomiasis is a parasitic disease caused by microscopic flatworm larvae known as schistosomes. These larvae develop inside freshwater snails, native to the Congo Basin, before entering surrounding water in search of a host. Infection requires no bite, no visible wound, and no damaged skin. Merely wading through contaminated water may allow the larvae to penetrate healthy skin and begin their life cycle within the human body. Worldwide, schistosomiasis affects more than 230 million people and ranks second only to malaria among the most devastating parasitic diseases. The Congo River system remains one of the regions where transmission continues as an everyday reality, adding an invisible biological threat to hazards already present above and below the water. Taken together, the pattern becomes striking. Extraordinary depth, crushing hydraulic force, specialized fish inhabiting different levels of the river, formidable predators near the surface, territorial mammals along the banks, venomous reptiles within the surrounding forest, and microscopic parasites drifting through the water all occupy their own place within the same environment. The Amazon possesses dangerous wildlife, yet the Congo assembles hazards throughout nearly every vertical layer of its landscape, extending from the deepest gorge to the forest canopy. Long before modern science recognized this architecture, explorers discovered its consequences through experience, and one expedition in the 19th century would reveal just how unforgiving the river could become. By the final decades of the 19th century, one question still lingered across the maps of Africa. The continent's great rivers had gradually surrendered their courses to explorers, surveyors, and cartographers, yet one immense waterway still concealed its complete path. The Congo remained unfinished, disappearing into the interior before emerging again at the Atlantic through a route no outsider had successfully traced from beginning to end. Solving that mystery became one of the greatest geographic ambitions of the age. Henry Morton Stanley believed careful preparation could succeed where earlier attempts had failed. Born in Wales and working as a journalist for the New York Herald and Britain's Daily Telegraph, he had already achieved worldwide recognition after locating Dr. David Livingstone during 1871. Years spent traveling through Africa convinced him that rivers demanded respect as much as determination, and he devoted considerable effort to planning an expedition capable of enduring conditions unlike any encountered elsewhere. One of Stanley's most important innovations appeared before the expedition even departed. He commissioned sectional boats that could be dismantled into smaller pieces whenever navigation became impossible. Porters would carry each component around cataracts and impassable reaches before reassembling the vessels farther downstream. Conventional boats could not survive such a journey intact. Stanley understood that progress would depend upon adapting constantly to the river instead of attempting to overpower it. The expedition departed on November 12, 1874, with a starting party of 356 people. Their objective reached far beyond exploration alone. They hoped to reveal the Congo's complete course and settle one of geography's greatest remaining uncertainties. Every mile carried them deeper into landscapes where maps offered little guidance and experience often became the only reliable source of judgment. The journey stretched across 999 exhausting days. Rapids claimed lives whenever exhausted travelers attempted passages that demanded more patience than strength. Disease spread through camps already weakened by hunger and relentless travel. Dense rainforest frequently limited opportunities to gather food, leaving many dependent upon dwindling supplies. Encounters with hostile communities added further hardship, while the river itself repeatedly forced detours around obstacles no preparation had fully anticipated. Every precaution seemed to encounter another challenge waiting farther downstream. Losses steadily accumulated until even Stanley's closest European companions disappeared. Frank Pocock, the last remaining European traveling beside him, drowned while attempting to negotiate dangerous rapids. His death marked another reminder that experience alone offered no guarantee of survival within the Congo system. The expedition continued, though its original company had been reduced beyond recognition. On August 9, 1877, Stanley finally reached the Portuguese outpost of Boma beside the Atlantic coast. Only 114 members of the original expedition remained alive. Approximately 68% of the entire party had perished during the crossing. Of the 4 Europeans who began the expedition, Stanley alone completed the journey. Among the Congo people, he became known as Bula Matari, often translated as breaker of rocks. The name reflected his persistent efforts to blast pathways and construct routes around cataracts that resisted direct navigation. Even so, the river never yielded completely. It accepted no permanent conquest, and its identity remained far older than any explorer's reputation. Stanley's greatest achievement was not mastery of the Congo, but understanding its course well enough to draw it accurately for the first time. His map answered where the river traveled from its distant interior to the sea. Many deeper questions remained untouched. The document revealed a route across Africa, while the river itself continued guarding the forces that shaped it and the extraordinary world concealed within its waters. There is a place where the Congo ceases to behave like a river that invites passage and becomes a force that refuses it entirely. Roughly 186 miles from the Atlantic coast, the broad waterway used by large trading vessels narrows with startling speed. The landscape tightens into a chain of steep gorges, and the Livingstone Falls begin. From that point onward, geography itself became the greatest obstacle to understanding the heart of the Congo Basin. The Livingstone Falls are not a single waterfall, but a succession of 32 distinct cataracts extending across about 220 miles. Over that distance, the river descends nearly 900 feet, while enormous volumes of water are compressed into channels that measure less than 300 feet across in some locations. Between roughly 1,400,000 and 1,500,000 cubic feet of water surge through these narrow passages every second, creating hydraulic forces unmatched by any ordinary river system. Measured by the sheer volume of moving water, the Livingstone Falls form the largest waterfall system on Earth. More water flows through this corridor than passes over Niagara Falls or Victoria Falls. The comparison illustrates an important distinction. Individual drops may appear less dramatic than famous vertical waterfalls, yet the total mass of water racing through the gorge exceeds any other waterfall system known. Power here comes from relentless discharge rather than towering height alone. For anyone attempting navigation, that distinction changes nothing. A vessel entering these cataracts cannot simply steer more carefully or rely upon greater experience. The combination of confined channels, violent gradients, and overwhelming current destroys boats regardless of design. This stretch of river presents a physical impossibility rather than a difficult passage. The river does not offer a navigable route because the landscape itself has eliminated one. Commerce eventually adapted in a way that science did not. During 1898, the Matadi-Kinshasa Railway reached completion after years of difficult construction. Built at enormous human cost, its purpose was straightforward. Goods arriving from the Atlantic coast could bypass the impassable cataracts before continuing by river into the navigable Middle Congo. The railway solved a commercial problem by avoiding the falls altogether, yet it contributed remarkably little toward understanding the extraordinary environment that had made such infrastructure necessary. This created an unusual geographic division. Communities and researchers traveling from the interior could move across the broad Middle Congo with relative efficiency. Travelers arriving from the coast encountered an entirely different reality once they reached the cataracts. Between those two approaches lay the lower Congo, isolated from practical access in either direction unless complex overland transport and careful logistical planning were added to every expedition. That isolation preserved more than difficult rapids. Within the lower reaches remained the extraordinary gorge descending about 720 feet, specialized fish adapted to crushing pressure, immense hydraulic systems, and river sections rarely examined in comprehensive scientific surveys. The discoveries described earlier emerged only because determined researchers accepted risks that discouraged almost everyone else. Vast portions of this remarkable landscape still receive far less attention than comparable rivers elsewhere in the world. For centuries, the Livingstone Falls acted as a boundary separating what could be reached from what could merely be imagined. They delayed exploration, redirected trade, shaped history, and preserved one of Earth's least studied major river systems. Even after the Congo finally escapes this barrier and reaches the Atlantic Ocean, its journey continues in a form unlike that of any other great river. Many rivers end with a gradual surrender. Freshwater spreads across the sea. Saltwater pushes inland with the tides, and the boundary between river and ocean slowly disappears. The Congo reaches the Atlantic in a remarkably different way. Even after traveling across the breadth of Central Africa, it retains enough force to preserve its identity long after crossing the shoreline, continuing a journey that extends far beyond the coast itself. At its mouth, the Congo releases approximately 1,250,000 cubic feet of water every second. That tremendous discharge carries vast quantities of suspended sediment gathered from forests, floodplains, and countless tributaries upstream. Instead of dispersing immediately into surrounding seawater, this dense outflow retains its momentum as it reaches the edge of the continental shelf. The river behaves less like water gently entering an ocean and more like a powerful current continuing along a predetermined path. This remarkable behavior produced one of the world's greatest submarine landscapes. Beginning at the river's mouth, the Congo Canyon stretches for about 500 miles across the floor of the Atlantic Ocean. In its deepest reaches, the canyon descends nearly 4,000 feet below the ocean's surface. Few submarine canyons combine such extraordinary length with such impressive depth, and fewer still remain so directly connected to an active river system. Unlike many underwater canyons formed during distant geological periods and later abandoned by changing coastlines, the Congo Canyon continues to evolve today. Powerful sediment-laden flows move through its channels again and again, carving, reshaping, and extending the canyon over immense spans of geological time. The river remains an active sculptor long after leaving the continent behind, carrying the work of erosion into an environment normally associated with waves and ocean currents rather than fresh water. A second expression of this unusual relationship appears above the canyon itself. Fresh water from the Congo forms an enormous plume floating across the Atlantic surface. This layer of relatively low salinity extends for roughly 500 miles offshore and can be detected from space as a distinct feature separating river water from surrounding ocean. From orbit, the boundary resembles another river spread across the sea, tracing the influence of Central Africa far beyond the coastline. Research published during July of 2026 revealed that this freshwater plume reaches even farther than scientists had previously estimated. Seasonal rotating ocean currents, known as mesoscale eddies, capture portions of the plume and transport them hundreds of miles beyond earlier models. Instead of remaining confined near the river's mouth, fresh water from the Congo becomes incorporated into slowly turning ocean systems that carry its influence across much broader areas of the Atlantic than expected. Comparison with the Amazon highlights how unusual this behavior truly is. The Amazon releases an even greater volume of fresh water into the Atlantic, yet its outflow disperses much more readily into surrounding seawater. The Congo follows another pattern. Its concentrated discharge continues through the submarine canyon, while its surface plume preserves a recognizable freshwater signature across remarkable distances. These two pathways, one along the seafloor and another across the ocean's surface, reveal a river that maintains its character in ways unmatched by any comparable system. The journey, therefore, does not conclude where land ends. The Congo extends its influence into the Atlantic, above and below the waves, shaping underwater landscapes while carrying fresh water across the open sea. Deep within the canyon, it continues to maintain. Conditions become so energetic that scientific instruments face extraordinary challenges, revealing another chapter in the river's long history of resisting careful observation. The journey continues long after the Congo disappears beneath the Atlantic. Within the great submarine canyon it carved across the ocean floor, another form of motion takes over. This movement is almost impossible to witness directly, yet it ranks among the most powerful natural processes ever measured beneath the sea. It begins when water becomes heavily loaded with suspended sediment, grows denser than the surrounding seawater, and starts descending the canyon under the pull of gravity. Scientists call these flows turbidity currents, underwater avalanches capable of reshaping the seafloor on an immense scale. Turbidity currents occur in submarine canyons around the world, although nowhere have they demonstrated the sustained strength observed within the Congo Canyon. Here, sediment supplied by the river feeds a system unlike any other. Once a current begins, it accelerates along the canyon floor while carrying enormous quantities of sand, mud, and organic material. Rather than fading after a brief surge, these dense underwater floods continue traveling for extraordinary distances with remarkable persistence. Careful measurements have recorded speeds ranging from approximately 2.3 feet per second to 11.5 feet per second. Individual events have maintained these velocities for more than a week without interruption. Such endurance distinguishes the Congo from other submarine canyons. This is not a brief collapse of sediment followed by calm conditions. It is a prolonged river of moving debris racing across the deep ocean floor for hundreds of miles before gradually losing momentum. Everything anchored within its path faces extraordinary forces. During the development of global communications, submarine telegraph cables were engineered to withstand demanding ocean conditions for years at a time. Even so, cables crossing the Congo Canyon were repeatedly snapped after powerful turbidity currents swept through. Engineers often discovered that failures occurred not because the equipment had weakened with age, but because the seafloor itself had moved beneath it. Modern scientific instruments have encountered similar difficulties. Researchers deploy moorings consisting of anchored cables fitted with sensors designed to collect months of information about deep ocean conditions. Within the Congo Canyon, many of these carefully positioned systems have disappeared or been destroyed after encounters with turbidity currents. Equipment intended to observe the canyon has repeatedly become another casualty of the very process it was built to measure. Observations reveal another remarkable connection. The largest turbidity currents consistently coincide with periods when the Congo River carries its greatest discharge toward the Atlantic. Seasonal increases in river flow deliver greater quantities of sediment into the canyon, creating the conditions necessary for especially powerful underwater avalanches. In practical terms, the river continues controlling events hundreds of miles offshore, linking conditions in Central Africa with geological activity far beneath the Atlantic Ocean. This relationship has produced an unusual scientific challenge. The Congo Canyon ranks among the least comprehensively studied major submarine landscapes on Earth, not because researchers lack interest, but because repeated attempts to monitor it encounter destructive natural forces. The same river system that complicated exploration across its interior now interferes with observation beneath the sea, extending its influence from tropical rainforest to the deep ocean. No other river combines such concentrated discharge, such an immense submarine canyon, and such energetic underwater sediment flows operating as parts of one continuous system. The depth of the lower gorge, the tremendous cataracts upstream, the canyon stretching across the Atlantic floor, and these persistent underwater avalanches all arise from the same remarkable geography. Each expression appears different, yet everyone is driven by a single landscape whose unusual form has shaped the Congo from its headwaters to the distant ocean. Some rivers breathe in long, predictable rhythms. They rise with seasonal rain, then gradually retreat as dry months return. Shorelines widen, currents ease, and channels become more accessible until another flood begins. Across much of the world, this cycle shapes the timing of exploration, commerce, and scientific research. The Congo follows a remarkably different calendar, one written by geography rather than by a single season. The distinction begins with the river's drainage basin. The Congo is the only major river on Earth whose watershed crosses the equator twice. That unusual arrangement divides its tributaries between opposite hemispheres. When rainfall reaches its seasonal maximum across the northern half of the basin, many southern tributaries are experiencing comparatively drier conditions. Months later, those patterns reverse. Rain shifts southward, while northern waterways begin to receive less precipitation. Each half alternates as the principal supplier of water, ensuring that one region continually replenishes the river while the other briefly recovers. This alternating cycle produces an extraordinary consequence. The Congo never experiences the prolonged seasonal recession characteristic of most great rivers. Water levels fluctuate, yet the system remains supplied throughout the year by rainfall arriving from opposite sides of the equator. There is no extended dry season when the river becomes substantially smaller, currents diminish for weeks, or broad reaches become consistently easier to examine. Its immense discharge persists through every month. For scientists, this continuity removes opportunities commonly available elsewhere. Rivers with pronounced seasonal variation often reveal their channels during lower water, exposing rock formations, simplifying measurements, and allowing expeditions to reach locations that remain inaccessible during flood periods. Researchers working in the Amazon, for example, regularly organize field seasons around predictable cycles of rising and falling water. The Congo offers no comparable interval when its enormous hydraulic energy retreats for an extended period. Its perpetual flow has shaped the river itself over immense spans of geological time. The extraordinary lower gorge, descending approximately 720 feet, owes its existence in part to water that has continued grinding against resistant bedrock without experiencing lengthy seasonal pauses. Sediment has little opportunity to accumulate deeply enough to soften the erosive process. Year after year, century after century, the current has continued carving along the same path with remarkable consistency. The same persistence explains why the Livingstone Falls remain such an effective natural barrier. Many river systems gradually bury rapids beneath accumulating sediment or experience seasons when reduced discharge creates less turbulent passages. Along the lower Congo, continual high flow prevents that transformation. The cataracts retain their tremendous power because the river never withdraws long enough for lasting change to overtake them. Far beyond the continent, the Atlantic still reflects this relentless pattern. Freshwater emerging from the Congo continues feeding the expansive plume already described, maintaining its influence across the ocean surface throughout the year. The submarine canyon likewise receives a continuing supply of sediment capable of sustaining the powerful underwater processes unfolding along its floor. From Central Africa to the deep Atlantic, every stage of the river remains connected through uninterrupted movement. This geographic arrangement has no close parallel among the world's major rivers. A watershed crossing the equator twice created a system with no meaningful pause, no dependable season of reduced force, and no extended interval inviting effortless exploration. The Congo has continued working without interruption for countless generations, shaping rock, transporting sediment, and sustaining one of the planet's most remarkable freshwater environments. Within that continual flow, another consequence gradually emerged, one measured not only in water and stone, but in the extraordinary abundance of life that came to inhabit the river itself. Life does not spread evenly across a river. In certain places, countless generations pass with little evolutionary change. In others, the environment continually reshapes every population that manages to survive. The lower Congo belongs to the second category. Its powerful currents, immense depths, and permanent hydraulic extremes have transformed a comparatively small stretch of freshwater into one of the richest centers of fish evolution ever documented. Although the lower Congo occupies less than 2% of the entire Congo basin, scientists have recorded 328 fish species within this limited reach. More than 80 of those species exist nowhere else on Earth. Such a concentration is extraordinary. Biological richness is impressive on its own, yet the unusually high proportion of endemic species reveals something even more remarkable. Evolution has repeatedly produced organisms that remain confined to this single section of river, unable to establish themselves anywhere beyond its distinctive conditions. The Amazon contains the greatest freshwater fish diversity on Earth when considered across its immense network of rivers extending roughly 4,000 miles. That diversity, however, is distributed across an enormous basin. The lower Congo achieves comparable richness within only about 200 miles. Its proportion of species found nowhere else is substantially higher than that of the Amazon's most diverse regions, making this relatively compact landscape one of the planet's most concentrated evolutionary laboratories. Several powerful forces work together to create these results. Earlier sections described how racing currents isolate neighboring fish populations, preventing regular movement even across surprisingly short distances. Those barriers remain in place throughout the year because the river never experiences a prolonged period of reduced flow. Deep channels, descending beyond approximately 520 feet, introduce crushing pressure and complete darkness, creating environmental conditions resembling portions of the deep ocean despite existing within fresh water. These conditions have repeatedly guided evolution toward the same destination. Scientists describe this pattern as convergent evolution, a process in which unrelated groups independently develop similar characteristics because they face identical environmental pressures. Within the lower Congo, cichlids, spiny eels, and several unrelated fish families have separately evolved reduced eyes, diminished pigmentation, and bodies capable of functioning under tremendous pressure. Each lineage began with different ancestors, yet the river continually favored comparable solutions. That repeated convergence demonstrates the remarkable strength of the environment itself. Distinct evolutionary histories have been redirected by the same hydraulic landscape until unrelated animals began resembling one another in important ways. The river has acted as a persistent filter, preserving adaptations that function within its demanding conditions, while gradually eliminating those that do not. The Goliath tigerfish offers another example shaped by this relentless setting. Its streamlined body, tremendous acceleration, and interlocking teeth reflect adaptation to exceptionally powerful currents. Predators inhabiting the Amazon evolved under different hydraulic conditions and therefore followed different evolutionary pathways. The Congo produced a hunter designed for levels of water movement rarely encountered elsewhere in freshwater ecosystems. Even today, this story remains incomplete. Scientists continue formally describing new species from the lower Congo on a regular basis, showing that its biological catalog is still expanding rather than approaching completion. Much of this remarkable diversity developed within a river system that remained only lightly explored by Western science until very recently. The obstacles delaying discovery arose from more than geography alone, revealing that the history of the Congo has always been shaped by both natural forces and human events. Knowledge often advances through repetition. Researchers return to the same place season after season, refining measurements, replacing instruments, and building observations that stretch across decades. Along the Congo, that familiar rhythm has rarely been possible. The river has resisted sustained scientific attention through a combination of extraordinary geography and prolonged political instability, leaving one of Earth's most important freshwater systems surprisingly difficult to measure in a consistent way. The first obstacle is physical. From the Atlantic Ocean, the Livingstone Falls block every attempt to travel upstream by vessel into the heart of the basin. Reaching the same region from inland presents a different challenge. Researchers must first navigate well over 1,000 miles of river before arriving at the upper boundary of the falls, only then confronting the section that has proven most difficult to study. Every expedition begins with an enormous logistical commitment before meaningful scientific work can even start. Geography alone, however, does not explain the scarcity of long-term observations. The largest portion of the Congo flows through the Democratic Republic of the Congo, a nation that has experienced repeated instability since gaining independence in 1960. Armed conflict, changing governments, weakened infrastructure, and economic hardship have repeatedly interrupted scientific programs that depend upon reliable transportation, stable institutions, and secure access to remote field locations. Even carefully planned research has often faced delays or cancellation because conditions changed faster than preparations could adapt. The consequences extended far beyond individual expeditions. During the colonial period, more than 400 river gauges were installed throughout the Congo Basin to monitor water levels and river discharge. Maintaining such a network required constant technical support, regular maintenance, and dependable funding. As political and economic conditions changed after independence, many stations gradually stopped operating. Instruments deteriorated, replacement parts became unavailable, and monitoring records grew increasingly fragmented until only a handful of gauges remained active across one of the world's largest river systems. Scientists therefore found themselves attempting to understand an immensely powerful river with an incomplete network of observations. Measurements became separated by large gaps in both time and distance. Entire sections lacked continuous records, making it difficult to describe long-term changes with confidence. Rapids blocked access, damaged equipment, limited new observations, and regional instability complicated efforts to restore monitoring systems that had once operated across much of the basin. The contrast with the Amazon illustrates how profoundly these circumstances shaped scientific progress. Researchers traveling to Manaus in Brazil can usually organize field campaigns within established research networks supported by transportation, laboratories, and long standing institutional partnerships. Comparable work within the Congo Basin often requires navigating administrative requirements involving numerous neighboring countries, while simultaneously addressing security concerns rarely encountered during equivalent studies in South America. Recognizing how little remained understood, an international collaboration known as the Congo River User Hydraulics and Morphology Project assembled researchers from 5 universities spanning 3 continents. Supported by the Royal Society and the Government of the United Kingdom, the effort required 6 years of preparation before becoming one of the first large scale scientific expeditions of the modern era focused on the Congo Basin. That extraordinary commitment reflected the scale of the challenge as much as the importance of the river itself. When researchers finally returned to the water during 2017, they discovered that years of planning had opened only a small window into an immense system. Even after sustained international cooperation, vast stretches remained beyond detailed observation, reminding the scientific community that the Congo had preserved many of its secrets through the combined influence of natural barriers and human history. Some discoveries arrive through a single dramatic moment. Others emerge only after years of careful measurement, repeated crossings, and patient observation. For the Congo, that process began in earnest during 2017 when an international team launched what was, in practical terms, the first large scale scientific effort of the modern era to study the river directly. The work did not reveal a landscape behaving exactly as expected. Instead, it exposed how much of the accepted picture had been built upon surprisingly limited information. The expedition brought together researchers from the University of Leeds, the University of Kinshasa, Rhodes University, the University of Bristol, and the University of Dar es Salaam. Financial support came through the Royal Society, together with the Africa Capacity Building Initiative of the Government of the United Kingdom. Years of planning, international cooperation, logistical preparation, and local partnerships were required before systematic measurements could even begin on the water. The scientific equipment reflected how much river research had advanced, while the Congo remained comparatively understudied. Teams employed sonar to construct detailed maps of the riverbed. They used acoustic Doppler current profiling, a technique that measures water flow at multiple depths simultaneously by analyzing reflected sound waves, allowing researchers to observe the movement of the current throughout the water column instead of only at the surface. Sediment concentration analyses added another layer, revealing how suspended material traveled through different sections of the river. Fieldwork continued for 3 years. During that period, researchers surveyed approximately 1,050 miles between Kinshasa and Kisangani, covering roughly one-third of the Congo's total length. Even such an ambitious effort left substantial gaps. The exceptionally hazardous lower reaches below Kinshasa, including the deepest gorge and the most turbulent sections, could not be comprehensively surveyed despite the scale of the expedition. As observations accumulated, an important pattern emerged. Current behavior, underwater structure, and sediment transport repeatedly departed from expectations established by earlier models. Those earlier interpretations had relied upon scattered measurements collected over many decades, leaving scientists to interpolate across enormous stretches of river. Direct observations demonstrated that the Congo operates with a level of hydraulic complexity exceeding the predictions developed from those limited records. The findings also changed how researchers viewed the river's greatest depths. Measurements published during 2009 established the lower gorge at approximately 720 feet, making it the deepest known river on Earth. The new expedition did not treat that figure as a confirmed maximum. Instead, scientists concluded that additional unsurveyed sections of the lower gorge may descend even farther. Considerable portions remain beyond detailed measurement, leaving open the possibility that the deepest point has yet to be identified. Modern satellites have transformed the study of rivers across much of the planet, although the Congo presents unusual limitations. Dense forest canopy conceals tributaries, turbulent surface conditions complicate remote observations, and the most important scientific questions concern processes unfolding hundreds of feet below the water surface. Neither depth, pressure, nor submerged current structure can be measured adequately from orbit. Those answers still require instruments placed directly within the river itself. After 3 years of work, researchers possessed a clearer understanding than ever before, yet they had examined only part of an immense system. Even this incomplete picture demonstrated that the Congo occupies a category unlike any other river on Earth, providing enough evidence for meaningful comparison, while reminding scientists that some of its most remarkable reaches remain largely unexplored. Comparisons become meaningful only when they measure the same qualities. The Amazon and the Congo are both among the greatest rivers on Earth, each shaping continents, climates, and ecosystems on an immense scale. Their reputations often overlap in popular imagination, yet a careful examination of their physical behavior, biological communities, and scientific history reveals that they belong to different categories of natural systems. Fame and danger have never been identical measures. Depth alone begins separating the two. The deepest confirmed measurements within the Amazon reach approximately 330 feet. The Congo descends to approximately 720 feet, more than twice as deep. At those extraordinary depths, pressure reaches levels normally associated with the ocean twilight zone, creating conditions absent from any known section of the Amazon. Scientists also acknowledge that portions of the lower Congo remain unsurveyed, leaving open the possibility that even greater depths have yet to be measured. Current strength widens the difference. Large vessels regularly navigate extensive lower reaches of the Amazon before reaching the Atlantic. Along the Congo, the Livingstone Falls extend for roughly 220 miles, forming an uninterrupted barrier that no vessel can traverse. This obstacle remains one of the most formidable river passages on Earth, separating the lower river from the vast interior basin in a way unmatched by the Amazon. Geological activity tells a similar story. The Amazon generates immense seasonal floods and powerful currents capable of reshaping floodplains across northern South America. The Congo adds another dimension. It continues carving an exceptionally deep gorge, maintains a submarine canyon stretching approximately 500 miles into the Atlantic, and generates underwater turbidity currents powerful enough to destroy cables and scientific equipment resting on the ocean floor. Few rivers influence landscapes across both continents and deep oceans with such persistence. The comparison extends to living communities. The Amazon contains piranhas, black caimans, electric eels, anacondas, and candiru, each well known for unusual adaptations. The Congo supports Goliath tigerfish capable of pursuing substantial prey, Nile crocodiles responsible for documented fatal attacks, hippopotamuses associated with hundreds of deaths across Africa each year, black mambas, gaboon vipers, and parasites causing schistosomiasis. Together, these hazards create an unusually dense concentration of biological threats within one river system. Far below the surface, another distinction appears. The Amazon possesses no known freshwater environment, matching the Congo's deepest pressure adapted habitats. The lower Congo contains species such as Lamprologus lethops, together with multiple unrelated fish families that independently evolved reduced eyesight, diminished pigmentation, and adaptations to immense pressure through convergent evolution. More than 80 endemic fish species complete an ecosystem without close parallel in another major river. The contrast continues beyond the coastline. The Amazon gradually disperses into the Atlantic as fresh water mixes with seawater. The Congo remains organized far offshore, maintaining a submarine flow through its canyon while generating the world's most energetic known turbidity currents. Its influence continues across hundreds of miles of ocean rather than ending where land meets sea. Scientific understanding reflects these differences as well. The Amazon has been extensively explored, mapped, and studied for centuries. Modern large-scale investigation of the Congo arrived only recently, with substantial portions of its lower reaches still lacking comprehensive surveys. Even fundamental characteristics remain subjects of ongoing research. Taken together, depth, hydraulic force, geological activity, biological specialization, oceanic reach, and incomplete scientific knowledge present a consistent conclusion. The Amazon remains the world's most famous dangerous river. The Congo occupies another category entirely, defined by extremes that combine within a single, uninterrupted system and nowhere else on Earth. Few rivers offer such an extraordinary promise, while remaining so difficult to transform. Across the lower Congo, immense volumes of water descend through steep gradients every hour of every day, creating a concentration of natural energy unmatched by any other river system. Engineers have recognized this potential for generations, yet the same forces that shaped its remarkable landscape have also prevented humanity from fully harnessing its power. The Congo possesses the greatest hydroelectric potential of any river on Earth because two advantages exist together in the same place. Enormous discharge delivers tremendous volumes of flowing water, while dramatic elevation loss across the lower river converts that movement into exceptional kinetic energy. Few locations combine both ingredients on such a scale, making the lower Congo one of the most attractive sites ever identified for hydroelectric development. For decades, planners have proposed the Grand Inga project near the Inga Falls. If completed as envisioned, the facility would generate approximately 40,000 megawatts of electricity. That figure would surpass every hydroelectric installation currently operating anywhere in the world. The Three Gorges Dam in China, the largest existing hydroelectric facility, produces approximately 22,500 megawatts. Grand Inga would approach twice that capacity, representing an unprecedented expansion of electrical generation from a single river. Such output carries remarkable implications. Engineers estimate that approximately 40,000 megawatts could provide enough electricity to supply the entire African continent, serving all 54 countries and a population of roughly 1.4 billion people. Few infrastructure proposals anywhere have promised benefits across an entire continent on such a scale. The reality today remains far more modest. Two existing Inga dams operate along the lower Congo, together producing approximately 1,775 megawatts. That represents only about 4% of the projected capacity envisioned for the complete Grand Inga development. The overwhelming majority of the river's energy continues flowing downstream exactly as it has for thousands of years. Several obstacles have repeatedly delayed construction. Political instability within the Democratic Republic of the Congo has discouraged the sustained investment required for projects extending across decades. Building major infrastructure within the lower gorge also presents exceptional engineering challenges, where powerful currents, rugged terrain, and difficult access complicate every stage of construction. The logistical problems encountered by scientific expeditions become equally significant when transporting machinery, materials, and workers into the same demanding environment. Funding proposals have emerged repeatedly, only to stall before reaching completion. The result is a remarkable paradox. Water capable of generating more electricity than any hydroelectric system ever constructed continues passing the proposed site every second without being captured. The river remains difficult to contain for many of the same reasons it has resisted comprehensive scientific study. Its immense hydraulic power, remote setting, and long history of political uncertainty have combined to keep even the most ambitious engineering plans largely on paper. There is another consequence to consider. If Grand Inga were eventually completed, the lower Congo would almost certainly change in fundamental ways. Altered flow patterns would reshape the hydraulic conditions that produced pressure, adapted fish, carved extraordinary gorges, and drove the evolutionary processes found nowhere else on Earth. The river's biological uniqueness and its formidable physical character are inseparable expressions of the same natural system. For tens of thousands of years, communities living beside these waters encountered those forces without sonar, engineering models, or geological surveys. Their understanding followed another path, preserving the river's immense presence through stories that carried its mysteries from one generation to the next. Stories often appear wherever knowledge reaches its limits. They preserve memory, caution, and observation long before written records exist. Along the Congo Basin, one story has endured across generations with unusual persistence. Known as Mokel Mbembe, it occupies a place between folklore and landscape, reflecting a river whose deepest places remained beyond reliable human understanding for far longer than most regions of the world. The name comes from the Lingala language and is commonly translated as one who stops the flow of rivers. Related traditions offer other interpretations, including rainbow and mystery. Although the translations vary, each points towards something powerful enough to command respect within waterways that shaped everyday life. For communities living beside the Congo, rivers were not abstract features on a map. They determined travel, food, survival, and the boundaries between the familiar and the unknown. Descriptions passed through many Bantu communities portray a large, semi-aquatic animal with a long neck, substantial body, and broad tail. Modern readers often compare these accounts to long-necked sauropod dinosaurs because of their general appearance. The creature is commonly associated with remote swamps and lakes of the Upper Congo Basin, particularly Lake Teli in the Republic of the Congo, where dense vegetation and extensive wetlands have long limited exploration. Reports have continued for more than 100 years. Explorers, missionaries, local residents, and later researchers documented sightings or collected testimony describing an unfamiliar animal inhabiting isolated waterways. These accounts inspired multiple scientific expeditions organized specifically to search for physical evidence. Despite years of investigation, No expedition produced verifiable proof that such a creature exists. No bones, tissue, photographs, or other evidence have supported the existence of a surviving dinosaur or any unknown giant reptile within the basin. Modern science therefore reaches a clear conclusion. Nonavian dinosaurs disappeared during the Cretaceous Paleogene extinction event, approximately 66 million years ago. Every line of paleontological evidence supports that understanding. The Mokelembembe almost certainly does not exist in the form described throughout the legend. The enduring importance of the story lies elsewhere. It developed among communities living beside one of the least explored major river systems on Earth, a landscape that genuinely continued revealing unfamiliar forms of life. Earlier sections followed blind fish emerging from immense depths, species that perished after decompression before anyone understood why. Researchers continue describing previously unknown cichlids and other fishes from the Congo today, demonstrating that biological discovery within the basin remains an active process rather than a completed chapter. Within such an environment, uncertainty became part of ordinary experience. People encountered unusual animals, observed behaviors they could not explain, and traveled through waterways where scientific investigation had scarcely begun. Folklore filled spaces left open by incomplete knowledge, drawing upon repeated observations while extending beyond what anyone could confirm. That process differs fundamentally from invention without experience. It reflects an attempt to interpret a landscape whose natural history remained only partially visible. Few places on Earth still allow scientists to say, with complete honesty, that much of the deep water has never been directly examined. Along the Congo, that statement remains accurate. The boundary between the known and the unknown has endured far longer than in most of the world's great rivers, giving legends such as Mokelembembe an unusually meaningful historical setting. The communities who carried these traditions were therefore never separate from the river's scientific story. Their observations accumulated across countless generations, preserving knowledge of seasons, waterways, animals, and changing landscapes that modern research is only beginning to appreciate alongside its own discoveries. Maps often give the impression that knowledge begins when a landscape is surveyed. The Congo tells a different story. Long before research vessels, sonar, and scientific expeditions entered its waters, millions of people already understood the river through daily experience. Their knowledge accumulated across countless generations, shaped by observation, memory, and survival, creating one of the longest continuous relationships between human communities and a major river anywhere on Earth. Today, the Congo Basin is home to approximately 75 to 90 million people living across 6 countries. Around 60 million depend directly upon its forests, rivers, wetlands, and tributaries for food, medicine, transportation, shelter, and livelihoods. The basin is therefore much more than a remarkable natural system. It remains one of the world's largest inhabited landscapes, supporting communities whose daily lives continue to follow the rhythms of its waterways. Human occupation extends back more than 50,000 years, placing the basin among Earth's oldest continuously inhabited regions. Across this immense landscape, many cultures developed detailed familiarity with local environments. The Muti people of the Ituri forest cultivated generations of ecological understanding within dense rainforest. Bantu-speaking communities established settlements along the river's length, adapting to changing seasons, fisheries, and flood cycles. Fishing communities near Kinshasa, Kisangani, and countless smaller settlements learned to recognize subtle patterns that determined safe travel and successful harvests. That knowledge rarely existed as written manuals or scientific reports. It was preserved through repeated experience and shared across families and communities. People recognized places where hippopotamuses gathered during particular seasons, identified stretches where currents shifted without obvious warning, and distinguished the changing sounds of moving water that sometimes preceded dangerous hydraulic events. Such observations were refined over centuries because mistakes often carried immediate consequences. Despite its practical value, much of this accumulated understanding remained largely absent from scientific literature. Researchers frequently arrived with instruments, measurements, and carefully designed field methods, yet comparatively little attention was devoted to documenting the experience of those who had spent entire lifetimes navigating the river. Scientific knowledge and local knowledge often developed along separate paths, even while describing the same environment. Earlier stories surrounding Mokele Mumbai illustrate this distinction. The legend itself does not provide evidence for the survival of a prehistoric animal. Its continued importance lies in demonstrating that local communities recognize the river as a place still capable of surprising human understanding. That perspective emerged within a basin where unfamiliar species genuinely continued appearing. The blind cichlid discussed earlier first attracted attention because local fishermen repeatedly noticed unusual pale fish washing onto the shore, long before researchers explained the effects of rapid decompression. Modern scientific efforts have gradually begun acknowledging this long standing partnership. The Congo River User Hydraulics and Morphology Project included formal meetings with local communities, government ministries, and river users as an essential component of its research program. Those conversations recognized that effective understanding of the basin required more than instruments alone. Practical experience gathered across generations offered observations that complemented modern scientific investigation. The Congo, therefore, should never be described as an unexplored wilderness. It has been home to tens of millions of people for thousands of generations, each contributing pieces of knowledge shaped by everyday life beside one of Earth's most demanding rivers. Scientific understanding continues, expanding through newly described species, improved measurements, and modern expeditions, yet it now advances alongside voices that have known these waters far longer, reminding us that discovery sometimes begins by listening as carefully as measuring. Some landscapes eventually settle into familiarity. Their maps become complete, their wildlife cataloged, and their deepest measurements confirmed through repeated observation. The Congo continues following another path. Even in the present decade, it remains a river where fundamental discoveries are still entering the scientific record, revealing that what appears established today may become incomplete tomorrow. One of the clearest examples emerged during June of 2025. Researchers completed the first comprehensive mitochondrial genome analysis of Lamprologus lethops, the only known blind cichlid, together with 7 closely related river-dwelling members of the same evolutionary group. The study strengthened evidence that this remarkable fish evolved directly within the lower Congo itself, adapting over time to the extraordinary hydraulic environment instead of arriving from elsewhere. Even after decades of biological investigation, one of the river's most unusual inhabitants continued revealing entirely new chapters of its evolutionary history. Fresh discoveries have extended beyond living organisms. During July of 2026, researchers published new modeling of the Congo River freshwater plume after it enters the Atlantic Ocean. The work demonstrated that rotating ocean features, known as mesoscale eddies, transport fresh water hundreds of miles farther offshore than earlier models predicted. The river's influence, therefore, extends across a larger portion of the Atlantic than scientists had previously recognized, expanding understanding of how the Congo interacts with marine ecosystems far beyond the African coastline. The river's greatest depths also remain unresolved. Approximately 720 feet remains the deepest confirmed measurement collected within the lower gorge, making the Congo the deepest known river on Earth. Researchers studying that section have repeatedly emphasized that substantial portions of the gorge remain unmeasured. Existing surveys therefore establish a confirmed minimum rather than an unquestionable maximum. The deepest river ever documented may still conceal deeper channels awaiting direct observation. Biological discovery follows the same pattern. The lower Congo currently contains 328 recorded fish species, including more than 80 found nowhere else on Earth. Those numbers continue increasing as researchers formally describe additional species from collections and field surveys. Each newly documented fish demonstrates that the basin remains scientifically active instead of historically complete. The current totals represent the lowest confirmed counts, not permanent limits on the river's diversity. Far beyond the river mouth, another frontier continues into darkness. The Congo Canyon extends for approximately 500 miles beneath the Atlantic before reaching depths approaching 4,000 feet. Much of its deepest biological community and geological structure has never been observed directly by scientific instruments. Researchers understand its overall form and remarkable turbidity currents. Yet many details of the canyon's ecology remain unknown because exploration at those depths remains technically demanding. Together, these ongoing discoveries distinguish the Congo from nearly every other major river system on Earth. Many great rivers are monitored through mature scientific networks that primarily document change within already familiar environments. The Congo continues introducing itself to science piece by piece. New genetic evidence, expanding oceanographic understanding, additional species, and unresolved depth measurements all illustrate a river whose scientific story remains unfinished in 2026. This continuing uncertainty carries an unexpected consequence. Nearly every major river on Earth bears unmistakable signs of extensive human alteration through dams, industrial development, or widespread engineering. The Congo has avoided much of that transformation because the same characteristics that challenged explorers, delayed scientific research, and complicated infrastructure have also limited large-scale human modification, allowing one of Earth's greatest rivers to remain unusually resilient while discovery continues. Many of the world's great rivers now carry unmistakable signatures of human alteration. Their channels have been redirected, their seasonal rhythms regulated, and their surrounding landscapes reshaped to support expanding populations. The Congo presents a striking exception. Much of its character remains remarkably close to the conditions that shaped it over millions of years, preserved by the same formidable forces that have challenged explorers, scientists, and engineers alike. The contrast becomes clear when viewed beside other major river systems. Across the Amazon basin, widespread deforestation has reached a scale that measurably influences the river itself. Forests recycle enormous quantities of moisture back into the atmosphere, helping generate rainfall that sustains the basin. As forest cover declines, satellite observations show reductions in this moisture recycling process. weakening one of the natural systems that continually replenishes the Amazon's water supply. Elsewhere, similar patterns appear through different causes. The Nile has been extensively transformed by dams and water regulation. The Yangtze has experienced large scale engineering and habitat change. The Colorado frequently fails to reach the sea because so much of its water is diverted for agriculture and cities. The Mekong continues adapting to increasing dam construction, while the Ganges faces persistent pressures from pollution, extraction, and dense human settlement. Across these rivers, altered flow, warmer water, declining biodiversity, or extensive physical modification have become familiar themes. The Congo Basin follows another course. Approximately 70% of its original forest cover remains intact, a proportion substantially higher than that of the modern Amazon basin. Positioned across the equator, the basin receives rainfall from atmospheric systems operating in both hemispheres throughout the year. This unusual arrangement contributes to projections identifying the Congo as one of the most climate resilient large river systems during the coming decades, allowing its forests and waterways to maintain remarkable stability despite broader environmental change. Its future, however, is not guaranteed. If the proposed Grand Inga project were completed in its fullest form, the lower Congo would experience profound hydraulic transformation. Water movement through the deep gorges would change, altering the pressure gradients, current patterns, and flow conditions that gradually produced blind cichlids and many other endemic species. Ecological relationships, established over millions of years, would respond to a river no longer behaving exactly as before. At present, comprehensive international protection has not preserved these conditions. No single treaty has prevented large-scale transformation throughout the basin. The river has instead remained comparatively unchanged because of characteristics that repeatedly discouraged intensive development. The Livingstone Falls interrupt access from the Atlantic. Extraordinary depths complicate engineering. Powerful currents challenge construction, while political instability within the Democratic Republic of the Congo has delayed ambitious infrastructure for decades. Together, these barriers have limited human modification more effectively than many formal conservation policies. An unexpected relationship therefore emerges. The qualities that make the Congo the most dangerous major river on Earth are also the qualities that have protected its natural character. Physical danger, hydraulic force, difficult geography, and limited accessibility have acted as enduring barriers against widespread alteration, preserving an ecosystem whose complexity still reflects long natural evolution. This preservation carries an extraordinary implication. Humanity has invested greater technological effort into studying the surface of Mars than into directly exploring the floor of the lower Congo River. That comparison is not symbolic. It reflects the practical history of scientific exploration, revealing that one of Earth's greatest rivers remains among the least completely understood environments on our own planet. Distance is often treated as the greatest obstacle to discovery. It explains why distant worlds require decades of planning, immense budgets, and technologies capable of crossing millions of miles through space. The lower Congo offers a striking reversal of that expectation. One of humanity's least understood frontiers lies on our own planet, close enough to reach in days, yet still resisting comprehensive exploration after generations of effort. Mars has become one of the best documented planetary surfaces beyond Earth. Orbiting spacecraft have mapped large portions of its terrain at resolutions finer than 3 feet per pixel, revealing valleys, craters, dunes, and ancient river channels in remarkable detail. Robotic explorers such as Curiosity and Perseverance have crossed its surface, collecting rocks and recording environmental conditions. The InSight lander measured vibrations traveling through the planet's interior, while orbital missions assembled extensive topographic maps that transformed understanding of Martian geology. The lower Congo tells a very different story. Below approximately 400 feet, the riverbed has been measured only at isolated locations during the United States Geological Survey expedition of 2009 and later through the Congo River. User Hydraulics and Morphology project conducted between 2017 and 2020, a continuous, comprehensive map of the deepest gorge floor still does not exist. Large stretches remain connected only by inference between scattered measurements rather than by direct observation. The uncertainty extends beyond the river itself. Far offshore, the Congo Canyon continues beneath the Atlantic for approximately 500 miles before descending toward depths approaching 4,000 feet. No scientific instrument has directly explored its deepest reaches. Researchers understand that immense turbidity currents race through the canyon, transporting sediment across the ocean floor. Yet the biological communities, geological details, and current behavior within its deepest sections remain largely unknown. These comparisons become more remarkable when distance enters the picture. Mars circles the Sun at an average distance of approximately 140 million miles from Earth. The lower Congo Gorge lies roughly 200 miles from Kinshasa. The difference in scientific understanding cannot be explained by geography alone. The limiting factor has never been simple distance. It has been the extraordinary difficulty of operating within one of the planet's most physically demanding river systems. Again and again, the Congo has imposed costs that few research programs can sustain. Powerful currents complicate navigation, extreme depths challenge measurement, remote access slows logistics before fieldwork even begins. Far offshore, turbidity currents moving through the submarine canyon have damaged instruments anchored on the ocean floor, demonstrating that the river continues resisting investigation even after its waters have entered the Atlantic. Every stage of exploration demands equipment capable of enduring forces that routinely exceed ordinary scientific expectations. The result is an unusual inversion in modern exploration. Humanity possesses more detailed information about a neighboring planet than about substantial portions of a river flowing across Earth's surface. That conclusion is not rhetorical exaggeration. It reflects the accumulated technological record of orbital missions, rover expeditions, underwater surveys, and repeated attempts to measure the Congo's deepest environments. Few places illustrate the limits of human understanding with such clarity. The Congo remains dangerous in familiar ways through powerful currents, formidable wildlife, and difficult terrain. It also presents another challenge, one measured by incomplete maps, unanswered scientific questions, and environments that continue resisting direct observation. Among the many creatures shaped by those conditions, one small fish embodies that resistance with remarkable precision, surviving only within pressures that become fatal the moment it rises too close to the world above. Among all the creatures carried through the Congo's currents, none expresses the river's character more completely than a small white fish that almost never reaches the world above. Lamprologus lethops has become one of the basin's most remarkable scientific discoveries, not because it represents an exception to the Congo's rules, but because it embodies them with extraordinary precision. Its biology is the river written into living tissue. Seen for the first time, the fish appears strangely unfinished. Its body is pale, almost translucent. Its eyes never developed into functional organs. For many years, those features seemed like abnormalities, as though the animal had somehow failed to complete its growth. Modern genetic research tells a different story. This fish is not incomplete. It is the endpoint of millions of years of evolution within one of the most demanding freshwater environments on Earth. Far below the river's surface, permanent darkness removes every advantage that vision once provided. Maintaining eyes requires energy, and natural selection gradually favors traits that conserve valuable resources whenever they no longer serve a useful purpose. Over immense spans of time, the genes responsible for functional eyes did more than fall into disuse. They became inactive through evolutionary change, leaving behind a fish perfectly suited to an environment where sight offers no survival benefit. Its lack of color follows the same principle. Pigment protects, conceals, or communicates in places where light exists. Deep within the lower Congo, none of those functions remain useful. Generation after generation, the evolutionary cost of producing pigment outweighed its value. Gradually, the river stripped away unnecessary coloration until only a pale, almost transparent body remained. Nothing about its appearance reflects weakness. Every feature reflects efficiency. What survives is an animal shaped for crushing pressure, perpetual darkness, and astonishing hydraulic force. Its body functions within conditions that would overwhelm almost every other freshwater fish known to science. The environment that appears impossibly hostile from above became, over countless generations, the only place where this species could truly thrive. Every adaptation represents a conversation between life and the river, conducted over millions of years without pause. That conversation carries a remarkable consequence. When powerful currents occasionally sweep an individual upward from the depths, the journey does not end with escape. The rapid reduction in pressure causes fatal decompression before the fish can survive near the surface. Brighter water contains abundant oxygen and countless other forms of life, yet those apparent advantages cannot compensate for the sudden loss of the immense pressure upon which its body depends. The safer looking world becomes the more dangerous one. Within that single life story lies a reflection of the Congo itself. The river has produced organisms capable of existing only within its own extraordinary conditions. Remove those conditions, and the adaptations that once guaranteed survival become impossible to sustain. The river and its inhabitants cannot be separated from one another because each has shaped the other across geological time. The same pattern echoes throughout the broader history of the Congo. Explorers arrived seeking passage and encountered currents beyond expectation. Scientists deployed instruments that returned only fragments of the story. Equipment lowered into the deepest channels, and the submarine canyon met forces capable of overwhelming, carefully engineered technology. Again and again, the river preserved its own character through conditions that resisted every straightforward attempt at understanding. Lamprologus lethops therefore stands as far more than an unusual fish. It is living evidence that the Congo has created forms of life inseparable from its own extremes, revealing a river whose greatest danger has never been an obstacle standing apart from life, but the very force that made such life possible in the first place. There comes a point where accumulating more facts no longer changes the nature of a subject. Instead, the subject itself begins changing the questions that can reasonably be asked. The Congo reaches that point with unusual consistency. It does not emerge merely as the world's most dangerous river. It becomes something more difficult to define, a place where the limits of human knowledge are revealed through repeated encounters with a landscape that has never fully yielded to investigation. Many forms of danger become manageable once they are measured. Crocodile populations can be surveyed, flood frequencies can be calculated, water chemistry can be analyzed. Current speeds can be recorded and incorporated into predictive models. Rivers such as the Amazon contain undeniable hazards, yet those hazards have gradually become documented, categorized, and increasingly predictable through sustained observation. Preparation grows more effective as understanding becomes more complete. The Congo resists that progression. Its deepest channels remain only partially measured. Scientists continue expanding the inventory of species living within its waters. Hydraulic behavior inside the lower gorge is understood through models that still depend upon incomplete observations. The submarine canyon, extending beneath the Atlantic, has never been comprehensively explored. Even the river's greatest depth remains an open, scientific question rather than a settled measurement. Important pieces of the system remain absent from the map itself. Such uncertainty changes the nature of risk. A danger that cannot be fully quantified cannot be planned against with complete confidence. The greatest challenge presented by the Congo is therefore not any individual crocodile, rapid, whirlpool, or submerged obstacle. It is the persistent difference between what the river appears to reveal and what it actually contains beneath its surface, within its currents, and throughout its deepest passages. The lives already encountered along this journey illustrate that distinction with remarkable clarity. Hendry Coetzee did not perish because he ignored obvious warning signs. He entered water that appeared calm until a crocodile transformed appearance into reality within a single instant. His experience reflected the river's capacity to conceal decisive information until the moment it mattered most. Henry Morton Stanley, likewise, prepared more thoroughly than nearly anyone before him. His expedition carried supplies, planning, and determination unmatched by earlier attempts. Even so, 242 members of his expedition never completed the journey. The river's demands exceeded preparation itself, demonstrating that careful planning cannot compensate for conditions that remain only partially understood. The same principle appears within the life of Lamprologus lethops. The blind cichlid does not rise toward the surface through weakness or failure. The river's own hydraulic forces carry it upward, placing its perfectly adapted body into pressures it cannot survive. The mechanism that created the species also contains the possibility of its destruction, not through malice, but through ordinary operation. This perspective changes the way the Congo can be understood. The river does not deceive, trap, or choose. It simply exists according to physical laws whose full complexity continues exceeding our ability to observe, model, and predict them in every circumstance. Human knowledge repeatedly encounters boundaries that the river neither recognizes nor adjusts to accommodate. Across much of the world, major rivers continue changing under dams, extraction, engineering, pollution, and expanding development. The Congo has remained comparatively beyond that reach because every attempt to transform it first encounters the practical limits of access. More than 150 years of sustained exploration, scientific investigation, and engineering ambition have demonstrated a consistent reality. Humanity can alter only what it can reliably reach, measure, and control, and the Congo continues placing substantial portions of itself beyond all three. The story of a great river is often measured by what remains after centuries of human use. Across the world, those stories increasingly describe reduction. Water that once flowed freely is diverted. Sediment settles behind dams instead of nourishing distant coastlines. Forests disappear, migrations falter, and ecosystems slowly adjust to conditions they never evolved to face. Against that broad pattern, the Congo continues tracing a remarkably different course. The Amazon remains the largest river by volume, sustaining one of Earth's richest biological landscapes. Even so, extensive deforestation within its basin has begun altering the natural cycle that helped create its own rainfall. Forests return enormous amounts of water vapor to the atmosphere through moisture recycling, feeding future storms across the basin. As those forests shrink, satellite observations show measurable reductions in that recycling process, gradually weakening one of the natural systems that has long sustained the river itself. Far to the north, the Nile illustrates another consequence of large scale engineering. Dams constructed along its course now trap much of the sediment that once traveled uninterrupted toward the Mediterranean Sea. For thousands of years, that sediment steadily replenished the Nile Delta. Today, reduced sediment delivery contributes to coastal erosion, allowing parts of the delta to retreat as waves gradually reclaim land the river once continually rebuilt. The Colorado River presents an even more striking transformation. Heavy withdrawals for agriculture and expanding cities have reduced its flow so extensively that, during most years, the river never reaches the Gulf of California. Water that once completed an uninterrupted journey across the American Southwest now disappears into irrigation systems, reservoirs, and growing communities before arriving at the sea. The Yangtze has followed its own path of alteration. Construction of the Three Gorges Dam fundamentally changed sediment transport, seasonal flow, water temperature, and migration routes for many aquatic species. Among the most poignant consequences was the disappearance of the Yangtze River dolphin, known as the baiji, which was declared functionally extinct during 2006 after decades of population decline within an increasingly transformed river system. The Congo stands apart from each of these examples. Its lower gorge continues slowly carving deeper into ancient rock through immense hydraulic energy. New fish species continue entering the scientific record, including discoveries formally described during 2025. Oceanographers studying its submarine canyon documented fresh evidence during 2026 showing turbidity currents capable of damaging equipment positioned on the ocean floor. At the same time, researchers demonstrated that the river's freshwater plume reaches farther into the Atlantic than earlier scientific models had recognized. These continuing discoveries unfold without the framework that protects many celebrated natural landscapes. The Congo does not owe its remarkable condition primarily to international treaties or comprehensive conservation agreements. Instead, its preservation has emerged from characteristics that repeatedly discouraged extensive development. Extraordinary depths, immense currents, difficult access, challenging terrain, and persistent logistical obstacles have collectively limited the scale of human transformation across much of the basin. An unusual relationship therefore becomes clear. The same forces responsible for making the Congo the most dangerous major river on Earth have also reduced humanity's ability to reshape it. While many other great rivers steadily lose pieces of their original character, the Congo continues following processes established millions of years ago, deepening its gorge, generating new evolutionary pathways, and carrying fresh water into the Atlantic, according to rhythms that remain only partially understood. Its enduring resilience reflects neither accident nor policy, but the extraordinary physical reality of a river that has consistently remained more difficult to alter than almost any other on Earth. There is a difference between solving a mystery and recognizing that a mystery remains. Human history often celebrates each new discovery as another boundary crossed, another uncertainty transformed into knowledge. The Congo invites a different conclusion. It continues flowing with complete indifference to whether anyone understands it, reminding us that the world still contains places whose fullest reality exists beyond the reach of present observation. The achievements of modern science are extraordinary. Researchers have sequenced the human genome, revealing the biological instructions carried within every cell. Telescopes have captured images of black holes once believed impossible to observe directly. Spacecraft have landed on Mars, traversed its surface, and returned detailed records of another world's geology. Instruments have measured the faint glow left behind by the earliest moments of the universe and explored the behavior of matter at scales far smaller than the eye can perceive. Against those accomplishments stands an unexpected contrast. Within the lower Congo, roughly 200 miles from a major capital city, the deepest portion of the gorge has never been comprehensively mapped. No systematic biological survey has documented every form of life inhabiting those depths. Scientific instruments lowered into its most demanding environments have repeatedly encountered forces capable of ending expeditions before complete measurements could be collected. The absence of complete knowledge persists despite determined effort rather than because of neglect. This distinction matters. It does not represent a failure of scientific inquiry or a lack of curiosity. Science progresses by confronting difficult questions with better tools, improved methods, and careful evidence. The Congo simply remains a place whose physical realities continue exceeding the capabilities presently available to investigate every corner of its hidden landscape. Within those unexplored depths, several possibilities remain equally reasonable. One future expedition may discover ecosystems composed primarily of additional pressure, adapted cichlids, spiny eels with greatly reduced eyes, and other animals following evolutionary patterns already recognized from earlier discoveries. Such findings would deepen understanding without fundamentally changing the broader picture of life within the gorge. Another possibility carries equal support from the evidence available today. Entire species may inhabit environments unlike any other freshwater habitat on Earth, shaped by combinations of pressure, darkness, current, and isolation found nowhere else. They may have evolved biological solutions never before observed, remaining beyond every camera, sampling device, or remotely operated instrument deployed so far. Present knowledge cannot confidently exclude either outcome because the necessary observations have not yet been made. That uncertainty defines genuine ignorance in the scientific sense. It is not uncertainty waiting only a few weeks or months to disappear. It is an open space within knowledge itself, where evidence has not yet reached far enough to determine which explanation nature has chosen. The honest response is neither confident speculation nor premature certainty, but patience before unanswered questions. The Congo asks nothing of humanity because it possesses no awareness of our presence. Even so, its existence suggests a particular form of humility. A river on our own planet, extending approximately 2,920 miles and sustaining nearly 75 million people, can still conceal living worlds that no human being has directly witnessed. It is worth recognizing that such places remain possible. They remind us that discovery is not only the accumulation of answers, but also the willingness to accept that some frontiers continue existing exactly as they are, whether or not we ever reach them. Human beings naturally place themselves at the center of every story they tell. Expeditions become milestones, discoveries become turning points, maps fill with names, dates, and remembered achievements. The Congo offers a different perspective. It reminds us that nature possesses histories entirely independent of our own, unfolding across spans of time so immense that human presence becomes only a brief passing moment within a much longer narrative. The Livingstone Falls have thundered across resistant rock for millions of years. Their currents were already carving channels long before the earliest members of our species appeared. They continued unchanged as civilizations rose elsewhere across the planet. They were still roaring when Henry Morton Stanley struggled through their violence, and they continue today with no greater awareness of modern cities than they held for ancient forests. Long after today's settlements have changed beyond recognition, the river will continue following the same descent toward the Atlantic. A similar story unfolds far below the surface. Lamprologus lethops acquired its remarkable adaptations through millions of years of natural selection within the lower gorge. Eyes gradually disappeared because darkness rendered them unnecessary. Pigment faded because light never reached those depths. Pressure shaped every aspect of its body until survival became possible only within the conditions that produced it. The fish does not recognize that scientists collected specimens, sequenced genes, or described its biology. It continues navigating perpetual darkness through behaviors refined long before human beings walked upright. The Congo Canyon beneath the Atlantic carries the same indifference. Powerful turbidity currents have transported sediment across the ocean floor for immense stretches of geological time. Those currents did not become stronger when telegraph cables first crossed the seabed. They did not change direction when researchers anchored instruments in their path. Modern equipment entered a system already operating according to physical laws established millions of years earlier. The currents simply continued their work. Far above that submarine landscape, the river releases an immense plume of fresh water into the Atlantic. It stretches for approximately 500 miles, dispersing according to currents, density differences, and the persistent flow descending from Central Africa. The plume is neither display nor proclamation. It exists without audience, following the same physical principles whether observed by satellites, research vessels, or no observer at all. Human efforts within the Congo have carried profound meaning for those involved. Henry Morton Stanley's expedition endured 999 days before reaching its conclusion. Hendrik Coetzee lost his life while exploring waters he knew intimately. Scientists devoted 3 years of demanding fieldwork between 2017 and 2020 to better understand the river's extraordinary hydraulics. Each event occupies an important place within human history. None altered the river's ongoing processes in any measurable way. This distinction separates the Congo from many dangers people routinely confront. Familiar hazards often become less threatening as knowledge grows. Better forecasting reduces storm losses. Improved engineering strengthens bridges. Medical research transforms once deadly diseases into manageable conditions. The Congo's greatest challenge emerges from something deeper than incomplete preparation. Its defining forces arise from the structure of the river itself, from immense energy, geological age, evolutionary history, and physical conditions that remain unchanged by the arrival of another species attempting to understand them. The river is neither hostile nor welcoming. Those ideas belong to human experience, not to flowing water. The Congo operates across scales of time, pressure, erosion, and biological change where human presence carries no special status. We enter its system briefly, learn what we can, leave our own records behind, and the river continues exactly as before, its course shaped by realities in which our existence has never been a determining factor. At this very moment, while days end in one place and begin in another, the Congo continues its uninterrupted journey. It has done so across millions of years, wearing deeper passages through stone, shaping living creatures within perpetual darkness, and carrying fresh water toward the Atlantic without hesitation or pause. It neither waits for witnesses nor offers warnings before the next current gathers strength. The Livingstone Falls remain among the river's defining expressions of power, approximately 1,400,000 cubic feet of water surge through gorges narrower than 300 feet every second, producing the same relentless sound that greeted Henry Morton Stanley during his expedition. It is the same voice heard at the beginning of this journey through the Congo, unchanged by the generations that have come and gone. Those rapids continue producing the most powerful, sustained river flow known anywhere on Earth. Far below the surface, at approximately 520 feet within the lower Congo, Lamprologus lethops moves through complete darkness. Its pale body, absent functional eyes, and remarkable adaptation to immense pressure belong entirely to that hidden environment. It possesses no awareness of the world above, no knowledge of the sunlight reaching the surface, and no understanding that people have described its biology. It continues, following patterns established across millions of years of evolution, exactly as every generation before it has done. Beyond the river's mouth, approximately 500 miles into the Atlantic Ocean, fresh water continues spreading through surrounding salt water. Suspended sediments from Central Africa drift outward within that moving plume before descending toward deeper parts of the ocean. The river extends beyond its visible banks, carrying its influence far offshore through processes that have reshaped the eastern Atlantic for immense spans of geological time. Still farther below, within the Congo Canyon, seasonal equatorial rainfall has once again supplied the conditions capable of triggering turbidity currents. Dense flows of sediment race downslope across the canyon floor, transporting enormous quantities of material while reshaping the landscape beneath the sea. Whatever lies in their path becomes part of an ongoing geological process that began long before the earliest human footsteps crossed the Congo Basin and continues without interruption today. The Amazon remains Earth's most widely recognized river, celebrated for its scale and extraordinary biodiversity. The Congo occupies a different place within the natural world. It carries unmatched hydraulic power, contains the planet's deepest river channel, shelters organisms that continue expanding scientific knowledge, and still preserves extensive regions where complete understanding has not yet been achieved. None of those qualities exists to demonstrate superiority. Rivers make no arguments. They possess no desire to impress those who study them. The Congo simply follows gravity through channels that descend to approximately 720 feet, sustaining creatures ranging from the blind cichlid to the Goliath tigerfish, the Nile crocodile, and the black mamba moving through vegetation along its banks. It crosses the equator twice, enters the Atlantic, extends into the ocean beyond its mouth, and continues slowly deepening portions of its remarkable gorge. Humanity has given the river a name. We have traced much of its surface, documented many of its inhabitants, and lost lives while attempting to understand it more completely. During 2026, that effort remains unfinished. After everything learned across centuries of exploration and science, we are still beginning the introduction. The river continues.